In 1897, J. J. Thomson, a British physicist, conducted experiments with electricity in low-pressure gas tubes. This led to a monumental discovery which changed the world of physics forever. So what revolutionary insight did he gain from the experiments? Let's find out. To study electricity in gases, special tubes were invented. One such tube was the cathode ray tube. In a cathode ray tube, there are two metallic plates. The cathode connected to the negative terminal of a battery, and the anode connected to the positive terminal. These plates are enclosed in a glass tube from which most of the gas has been removed, creating a partial vacuum. When the device is activated, the cathode emits a beam directed toward the anode. This beam is known as cathode rays. Thomson wanted to know more about this mysterious beam. So let's explore his key observations and the conclusions he made from this experiment. To find out whether cathode rays were composed of waves or particles, Thomson placed an object in their path. Now let's say that the rays were made up of waves, then the rays would bend near the object due to the diffraction of waves. But this did not happen. Instead, the rays traveled in a straight line, casting a sharp shadow behind the object. This suggested that they were made of particles rather than waves. Next, a wheel was placed in the path of the beam. If light were to simply shine on the wheel, it wouldn't move, since light has no mass to push the wheel with. But in this case, the wheel rotated, indicating that the beam consisted of particles with mass. When a magnet was brought near the beam, it deflected, showing the beam responding to magnetic fields. Also, when a positively charged plate was brought near the tube, the beam bent toward it. This indicated that particles carried a negative charge. To see whether the particles depended on the materials used, Thomson repeated the experiment with different metals like zinc, copper, platinum, nickel, and also different gases inside the tube like hydrogen, neon, nitrogen. Regardless of the materials used, the beam behaved the same way. This showed that the particles were present in all the materials. Before we move to the most profound conclusion, let's briefly consider some historical context. By the 19th century, the existence of atoms had already been proposed. John Dalton theorized that matter is made up of indivisible atoms, with each element consisting of its own type. Dmitri Mendeleev developed the periodic table organizing elements by atomic weights. At that time, hydrogen was considered the lightest and simplest atom, and many believed no particle could be smaller than a hydrogen atom. But now comes the breakthrough. In the cathode ray tube experiment, Thomson, using a physics math technique, discovered that these particles were almost 2,000 times lighter than hydrogen atoms. This proved that there existed a tiny negatively charged particle much smaller than the hydrogen atom. These particles were later named as electrons.